In this video, we're going to start edging towards talking about what are called binomial random variables, as well as just doing kind of a final review on combining random variables. So, 70% of all men save some holiday shopping for December 24th. You survey 5 men. Find the probability that all 5, okay? I'm going to, instead of writing down the answers, I'm going to just kind of show some work here. So, if 70% of men do save shopping, and all, so this would be 0.7 raised to the 5th power. That would be all 5. None of the 5 save some shopping for December 24th. Well, of course, if 70% do, 30% don't. So this will be a 0.3 to the 5th power. At least one man. Okay, let me just quickly talk about this random variable and what values it could take on. You could have 0 men, 1, 2, 3, 4, and 5. So this represents the sample space. There are 6 outcomes here. If you ask 5 men, between 0 and 5 could say yes. So at least one represents the sum of these numbers here. So notice 0 is left out. So those things are complements of each other. 0 and at least 1. So what I can do is I can use what I did in 2 and do 1 minus the probability of 0. Okay? And now 4 of the 5 men. So you say, well, it's going to be 0.7 to the 4th. It's going to be 0.3 to the 1st. Clean this up a little bit. 0.3 to the 1st. However, 4 of 5 men, there are multiple ways for that to happen. We could have yes, 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 no, yes, 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 no, yes. So I'm going to write some more possibilities here. There are 5 ways in which 4 of the 5 could say yes. So we have to take this answer and multiply it by 5. Now the nice thing is there's a nice quick way to do this on your calculator, where you would you want to know 5 or 4 out of 5. It's called a combination. Let me quick show you how that would look. So you can see my this calculator. Here's what you would do. To count these things up, you would first press the math button, and then you're given a menu along the top. You're going to scroll over with your arrow key to PRB, and you're going to choose the one that says NCR. You can see I've written it up here. And actually, you should have typed in a 5 first. So you say 5 men. And I want to know how many ways there are to get 4 out of 5, how many orders. And you can see it returns that 5, that multiplier here. This is called a combination. So it's basically saying how many ways are there to get 4 out of 5? How many different orders will that occur in? The typical math way to write this, at least in AP statistics, is we do kind of this big parentheses. And we write a 5 and a 4. Okay, so that represents this combination. It's how many ways, how many different orders are there to choose 4 out of 5. Okay, so again, it's on that Math PRB menu. All right, for the random variables, we're going to find the various transforms below. I'm going to begin by just filling in the mean and deviation for both x and y. Please remember those formulas. If you've forgotten how to do them, go back and look. The mean or expected value, remember, is the sum of probability times x, and the deviation is the square root of the sum of p times x minus that expected value squared. I'm going to fill those in. Okay, so you can see I've filled those values in using the formulas, and now I'm going to start going across here. Now, the expected value of x plus y. So the nice thing about about adding these things is, of course, you just do with the expected value exactly what you would want to do, which is just add the two expected values. 2 plus 3 plus 8.2 is 10.5. Let's keep going with the expected value. Expected value of tripling the random variable x. Well, if you triple the expected value, you get 6.9. That is expected value here. The expected value of taking your random variable x and subtracting y. So 2.3 minus 8.2 is negative 5.9. 5.9, excuse me. Change where my decimal is. If you double the random variable x and then add 3, you simply do that to the expected value. So 2.3 times 2 plus 3 is 7.6. And finally, if you have the random variable y and subtract 2, the new expected value is simply 8.2 minus 2. So the nice thing about expected value, it does exactly what you want it to do, right? Exactly what the formula says. We added our two expected values, we tripled the expected value, we subtracted, we doubled and added 3, we subtracted 2. Now, standard deviation. This is a little bit different. The formula, remember, we always work with variances. So what we do is we have to square our standard deviations to get back to variance, and then add them together, and then square root them to get back to talking about standard deviation. So if we do that, we get 1.89 here. Okay. Multiplying your standard deviation by 3, we really do just multiply it by 3. So it will be 0.46 multiplied by 3, which is 1.38. Subtracting deviations. This actually, whenever we combine random variables together, we increase the chance for variability. So it's actually the same exact formula and answer. It's still 1.89. We should never be subtracting our variances. Here, obviously doubling our deviation changes it. You know, 0.46 multiplied by 2 is 0.92. And then adding 3 doesn't change anything. So we simply multiply the deviation. And finally, taking our random variable and subtracting 2 does not change the deviation. Okay? So again, we've talked about these rules before, but when you're combining random variables, we square the standard deviations, add those variances together, and square root. Same as if we're subtracting. If we're tripling, or if we're multiplying, we can just multiply the deviation. If we're subtracting, nothing changes. Finally, I just wanted to pose the question that of the distribution. I've given you a distribution x, a random variable, and the distribution of doubling it versus the distribution of adding it together twice. I wanted to talk about if those things are the same. So first of all, let me draw the distribution to x. Let's just write down that table. So doubling x gives us outcomes of 2 and 4. The probability of doubling stays 0.4 and 0.6. Adding x plus x. So we still have 2, and we still have 4, but we also add an outcome of 3. Okay? I like to think about this like you're playing a game. The red represents double or nothing, right? You're going to play one time, you're just doubling your money. The blue represents you're going to play the game twice. So if you play the game twice, you might get a 1 the first time, you might get a 2 the second time. So that's why we have this new outcome. Where if all you're doing is doubling it, 3 is not a possible outcome. Okay? So I have to do a little more work now for probabilities. Getting a 2 means you got a 1 twice. So 0.4 times 0.4 is 0.16. And getting a 4 in this distribution is like you got a 2 twice. So 0.2 or 0.6 times 0.6 is 0.36. So using the idea of a sample space, I can fill in that this is 0.48. So right away, if you're asked, are the distributions the same? The answer is no, they're definitely not. Because in the blue, in this sum distribution, we have an outcome that wasn't even possible in the red. Not only that, the probabilities are different. Okay? So again, I like to think about, this is a double your money game. You're playing once and doubling the outcomes. This is saying, no, you're playing twice. Right? You're playing the game one time and then again. Now, I'm going to fill in the expected value and standard deviation for all three of these distributions, and then we can talk about the transforms. So you can see I have filled in using the formulas. I just went to the table, but now I think we can get some ideas of transforms. So the expected value here in the original was 1.6, and you can see doubling, no surprise, 3.2. We just doubled our old expected value. Adding two together, it was one play plus another play, it's 3.2. However, our deviation, our standard deviation, you can see if we doubled our distribution, we doubled our deviation. But that's not true here, because this formula was the sum of two games. Like that. And because square roots are not distributive, this is not the same as simply doubling the standard deviation. Now, the other part of this I want to draw your attention to, because you maybe see like the deviation has shrunk, and the reason is if the expected value is 3.2, we have added an outcome in this blue distribution, the highest probability outcome, and it's very near the expected value. That isn't possible over here. So that's why the variability has decreased. We've added a very probable outcome near the expected value. So again, this is kind of a difficult concept for people, because in algebra you think, well, x plus x is 2x. These are different situations, so you need to read problems carefully. Are we really tripling something, or are we adding three of the same thing together?